Hey everyone, welcome back. If you are studying IB chemistry, you have probably noticed that topic 3 is huge. Today, we are breaking down topic 3.2, classification of organic compounds from the new IB curriculum. We are going to cover everything: how to draw organic molecules, functional groups, homologous series, isomerism, and how structure affects physical properties. First up, how do we represent organic compounds? The IB wants you to interconvert between 5 different types of formulas. Let us start with empirical formula. This is the simplest whole number ratio of atoms. Like if we have C6H12O6, we divide everything by 6 and get CH2O. Easy. Next, molecular formula. This is just the actual number of atoms. No simplifying. Then we have full structural formula showing every single atom and bond. This takes forever to draw, so we use condensed structural formula instead, like CH3CH2OH for ethanol. Finally, skeletal formula. This is how chemists actually draw. Each corner or line end is a carbon. We do not bother drawing hydrogens. They are implied. The IB loves asking you to convert between these. Practice until it is automatic. Functional groups are the heart of organic chemistry. They determine what reactions a compound undergoes, its physical properties, and how we name it. Let us go through the main ones you need to know. Alkanes have single bonds only and use the suffix "ane". Alkanes have a double bond and use the suffix "ane". Alkanes have a triple bond and use the suffix "ane". Arenes have a benzene ring. Halogenoalkanes have fluorine, chlorine, bromine, or iodine. Now the oxygen-containing groups. Alcohols have the OH group and use the suffix "-ol". Aldehydes have the CHO group and use the suffix "-ol". Ketones have the CO group in the middle and use the suffix "-one". Carboxylic acids have the COOH group and use the suffix "-oic" acid. Esters have the COO group and use the suffix "-o-ate". And nitrogen-containing groups. Amines have the NH2 group and use the suffix "-amine". Nitriles have the CN group and use the suffix "-nitrile". Remember, the suffix tells you the primary functional group. A homologous series is basically a family of compounds. They share the same functional group, the same general formula, and each member differs by exactly one carbon, that is the CH2 group. As you go up the series, physical properties change predictably. Boiling points increase because you have more electrons, which means stronger London dispersion forces. But solubility decreases because the nonpolar carbon chain gets bigger and dominates over the polar group. Isomers are compounds with the same molecular formula but different structures. We have structural isomers, different arrangements of atoms. Chain isomers have different carbon skeletons, like pentane versus 2-methylbutane. Position isomers have the same functional group in a different position, like 1-propanol versus 2-propanol. Functional group isomers have different functional groups, like ethanol versus dimethyl ether, both C2H6O. And then we have stereoisomers, same atoms, but different three-dimensional arrangement. For geometric isomers, also called E, Z, or cis-trans, you need a carbon-carbon double bond and 2 different groups on each carbon of the double bond. Quick priority rule: higher atomic number equals higher priority. If the high priority groups are on opposite sides, that is E. Same side is Z. Finally, how does structure affect properties? 3 factors affect boiling point. Chain length: longer means more electrons, stronger London dispersion forces, higher boiling point. Branching: more branch means less surface contact, lower boiling point. Intermolecular forces: this is huge. London dispersion forces are the weakest. Every molecule has these. Dipole-dipole is medium, present in polar molecules only. Hydrogen bonding is the strongest when hydrogen bonds to nitrogen, oxygen, or fluorine. Compare ethanol versus ethanoic acid. Both have hydrogen bonding, but carboxylic acids have 2 oxygen atoms that can hydrogen bond, so they have higher boiling points. For solubility, remember, polar dissolves polar, like alcohols, in water. Nonpolar dissolves nonpolar, like oils, in hexane. The longer the carbon chain in an alcohol, the less soluble it becomes. And that is a wrap on topic 3.2. To recap, know all 5 formula types and how to convert, recognize 10 or more functional groups, understand homologous series trends, identify types of isomerism, and explain physical properties using intermolecular forces. That is everything you need for IB Chemistry 3.2. If this helped, make sure to like and subscribe and hit that notification bell so you do not miss my next videos. Thanks for watching. I will see you in the next one.